It is a tremendous honor for me to receive the Paul Ehrlich and Ludwig Darmstaedter Prize in this historical building, and on this birthday of Paul Ehrlich, who has been my scientific hero. I'm very happy to receive this prize together with Gran and Andrea. Both of them have made transformative contributions to our understanding of innate immunity. This prize is very special to me because it really shows that science has no border. I was born, raised, and educated in China, received research training, and did all my research work in the United States. And now I'm receiving this most prestigious prize in Germany, in the Paulskirche, that symbolizes unity and democracy. I treasure this prize much more now that we live in a world of tensions and uncertainties. I would like to express my sincere gratitude to Paul Ehrlich Foundation and members of the Scientific Council, chaired by Professor Thomas Baum, for giving me such a high honor. When I was growing up in a rural region in South China, I was told by the villagers that a dream job for a farm boy like me was a truck driver. But my parents knew there might be another way, and that was to send me to schools. And taking advantage of a fast-track education system back then, I attended Fujian Normal University at a young age. In my sophomore year, I took a biochemistry class by a teacher named Zhang Qi. I was enthralled by his teaching style and became hooked on biochemistry. In 1986, I was accepted into the PhD program in the biochemistry department of State University of New York at Buffalo. I was fortunate to join the laboratory of the late Cecile Picard, a pioneer in the enzymology of the ubiquitin pathway. Cecile taught me how to do protein purification and enzyme kinetics. I was also lucky to be co-mentored by Ed Niles, who taught me molecular cloning. These skills and training have proven invaluable throughout my research career. After my postdoctoral research on endotoxicity within the Burma at the Salk Institute, I was lured by Baxter Healthcare to work on a T-body project, which was the first generation CAR-T that didn't work. It was ahead of its time. In 1994, I moved to a startup company in Boston called ProScript, where I helped develop the proteasome inhibitor bortezomib, which is also called Velcade, which has been approved for the treatment of multiple myeloma. I was also able to do basic research in the company. In collaboration with many others at Harvard, I identified a kinase called the ICAP kinase complex that is important in the NF-κB pathway. Intrigued by these findings, I decided to return to academia. In 1997, I joined the University of Texas Southwestern Medical Center in Dallas as an assistant professor in the Department of Molecular Biology that was just set up by Eric Olson. In joining UT Southwestern and starting a lab right next to the Olson lab was the best move in my career. Eric is a brilliant biochemist and a charismatic leader. He leads by example, and he exemplifies the culture of UT Southwestern with various scientific excellence and collegiality. Such a culture was cultivated by Mike Brown and Joe Goldstein, who taught us how to make discovery after discovery in the most creative and rigorous way. The culture and environment at UT Southwestern allowed me to focus entirely in the lab. Shortly after starting my lab, my postdoc, Li Deng, discovered a unique form of polyubiquination that activates protein kinase, ushering an era of studying the role of ubiquitination in cell signaling. Inspired by Tom and others' work on interferon beta, I decided to start a new research program aiming to understand how interferon beta is induced by virus infection. In 2005, my student Rashu Seth discovered the mitochondrial antivirus signaling protein called MAPS, which plays a key role in immune defense against RNA viruses. And the name MAPS was inspired by the basketball team Dallas Mavericks, with Dirk Nowitzki as our all-time star, and I know the Nowitzki is a hometown hero here as well. Our work on MAPS, mediated RNA sensing, led us to study DNA sensing. And 3 years after we discovered MAPS, Glenn Barber identified STING, which functions similarly to MAPS, except that STING functions as an adapter in the DNA sensing pathway, whereas MAPS is an adapter in the RNA sensing pathway. And the crucial question for the field at the time was, what's the DNA sensor? As a biochemist, I decided to take a biochemical approach to identify the DNA sensor. It took my postdoc, Josh Sun, 2 years to establish an in vitro system that can detect the DNA sensing activity. It took Josh and my graduate student, Jiaxi Wu, another 2 years and more than 2,000 dishes of cells to purify the DNA sensor, which to our pleasant surprise turned out to be an enzyme that we now call cGAS. We found cGAS is activated by binding to double-stranded DNA, and the activated enzyme then converts GTP and ATP into a cyclic dinucleotide, cyclic GMP, AMP, or cGAM. And this cGAM molecule then functions as a high affinity ligand that binds and activates STING to galvanize a signaling cascade, leading to the production of heparin interferons and other cytokines. In subsequent work from many labs, including Glenn, Barber, Angela Blas, and our lab, firmly established the central role of the cGAS STING pathway in many physiological and pathological processes. It is truly gratifying to witness the rapid progress in the past decade, which lead to a very good understanding of the cGAS STING pathway, from atomic structures to mouse models and human diseases. In the next decade, I firmly believe we will witness fruitful translation of our basic discoveries into medicine that can benefit human patients with disease ranging from cancers to a variety of autoimmune and inflammatory diseases. I'm indebted to everyone in my lab for the dedication and contribution to the discovery that is being recognized by this prize. I wish to share this honor with the many scientists around the world for their contributions that lead to the very rapid advances in understanding the cGAS STING pathway. Finally, I want to thank my parents, my wife, Annie, who's here, and our daughters, Lily and Alyssa, for their love and support, without which I would not have come this far. Thank you very much.